Hi, in this video, I'm going to show another practical example of using higher order function in lambdas. And this is to write and also speed up a very simple web crawler. In simple terms, web crawlers, they just retrieve web pages. Now, they're used by search engines such as, say, Google to retrieve all of billions of web pages from the internet so that they can index them and provide efficient searches through them. So it can be a highly complex operation, but at a very, very basic level, if we're given a URL, say, the URL to the python.org, it just fetch the page from that URL. So we can do something very simple. We're going to use a built-in Python library called the URL lib. Use its request module, and all that it does is it opens a given URL. It reads the web page at that URL, and what we're doing here is just print out the number of bytes at that URL. So very simple. If we run this, we'll see that the page at python.org has about 50,000 kilobytes. Now, obviously, a web crawler doesn't just retrieve a single URL, right? So it's going to retrieve pages from multiple URL. And to do that, we can, well, just write a for loop, right? That goes through the list of URL. And for each one of them, we'll just do exactly the same thing. And we can even time how long it takes to retrieve this list of URLs. If we run this, now the speed is going to vary a lot depending on your home internet connection speed and the server speed and all that things. So in this particular case, it takes about 2.3 seconds to retrieve these 6 web pages. Now, the problem with using a for loop to do this is each web page is going to be retrieved only after the previous web page has been received. That's just how the for loop works, right? Because each iteration typically in a for loop may depend on the result from the previous iteration. So now, in case of fetching web pages, though, this is kind of unnecessary because if you look at the URL here, it really doesn't matter if we get python.org first before Netflix or the other way around. So the order does not matter. We don't have to do this loop strictly in the order of the URL that is specified in this list. So now to overcome this limitation, we cannot use for loop. So we have to look for an alternative, and that alternative is what's called the map function. So let me explain what the map function does. So the map function can, in some cases, replace the for loop. So what the for loop does very often is that it's used to process each of the elements in a list, right? So in this particular case, we have a list of 10 numbers, and we just want to, let's say, double those 10 numbers. And then in another loop, we want to triple those 10 numbers, and we want to create 2 lists as a result. Now, in either case, some operation is done to each of the elements, or in other words, some function is applied to each of these the elements. Now, this is actually a very common kind of processing that it can actually be very elegantly or beautifully expressed as a mapping operation. So, and Python has a built-in support for this kind of mapping operation in terms of the built-in map function. Now, this map function, it typically has 2 parameters. It can have more, and the first parameter is always a function, and the second parameter, and potentially third and fourth, so on, they are always some iterable, And what iterable is a data structure that can be iterated over. So oftentimes it's in the form of a list. Now, what the map function does is that for each element in this list, it applies that first parameter of function to it. So in this case, it is multiplying each of the element in L by 2. And now the map itself, it doesn't actually apply the operation. It just creates a map object. And in order to actually apply the function to the list, we'll have to convert it to an actual list. So that's what that is for. Now I have typed the code out here. The list I'm generating is just number from 0 through 9 inclusive. And I'm going to double all of them and create a new list. And indeed, that's what happened here. And if you want to give this a try yourself, and I highly encourage you to do so, is you can try to use the same idea of using map to replace this for loop that triple each of the element in a list. And here is the code for it, very similar to what we did for the doubles. Now, map actually looks similar to something you already know, and that is list comprehension. And in this case, we can also write doubles as a list comprehension of x multiplied by 2 for x in L, right? Now, then list comprehension actually looks simpler than using maps and lambdas and all that. But using map does have an advantage over list comprehension. I'll get to it now. So now we have an idea of how map works. We can go back our web crawler and we can replace our for loop with a map. And if you want to try it out yourself first, pause the video, give this a try. But now I'm going to show you how to use map in this case. And that will be my single fetch function. And I basically put this whole this body of the for loop inside a lambda function, and the parameter to the lambda will be the URL. So, right, that's the URL we're fetching and reading, and I'm going to map this whole lambda function to the list of URLs. Okay, and the rest of it is exactly the same in the as in the for loop, the for fetch. So I can run this, and it should do exactly the same thing as it did before, and the speed is the same mostly. So we haven't really done anything in terms of speeding things up, because between the for loop and the map function, map really does the same thing as the for loop, because it also fetches the URLs one after another. And in terms of fetching pages over the internet, because the computer, your CPU, is so much faster than the network speed, most of the time, it's your CPU just sitting there waiting for the data over the network to come back. So this is what's called serial processing, because again, it fetches the next URL only after the previous one is finished. Now, if you think about this a little more carefully, then you'll realize, hey, if I'm just sitting there most of the time waiting for things to come back, then why don't we send out a request or multiple requests at the same time, so that we can retrieve multiple pages at the same time, or in other words, do things in parallel, so that maybe we can fetch more pages in the same amount of time. So this is called parallel processing versus serial processing. Another name for it, you might have heard of it, is that it's multiprocessing. Now, multiprocessing is a fairly advanced topic. So, and that's usually discussed in the class on, say, distributed system. So, do we need a class in distributed system before we can do something like this? Well, it would definitely help, but the good thing is that we can actually take advantage of it without completely understanding of how the underlying mechanism works. And that is by doing or using Python's version of map that does parallel mapping. It might look a little intimidating, but let me break this down. So the first thing I'll do is I import from the standard package multiprocessing what's called a thread pool. Now threads are just execution streams, and multiple threads can go on at the same time. So things can be done in parallel. Now there's some limitation on how parallel it actually is in Python, but let's not worry about that technical detail. And the next thing we're going to do is we'll create a pool of threads. The number of threads I'm using for this run is 4. Higher number might improve the parallelism, but too many may cause too much overhead. So 4 is a good number to begin with. And now instead of using Python's built-in map, I'm going to use the pool map. Okay, and what that does is it takes the lambda function and it takes a list of URLs, a list of things that the lambda function is going to work on. And by the way, it's very important that this lambda function here is the exact same lambda function that I use in the single serial fetch case. Okay, so nothing changes in the lambda functions itself. It's just the map function is changed from the built-in map function to the pools map function. So the pools map function will map the lambda to any one of the 4 threads that we created. So potentially 4 lambda can be executed at one time. And then there's some other bookkeeping here for the pool thread things. And then everything else is exactly the same. Now let's see how well it runs. I'm going to run the single fetch and then the parallel fetch. So, okay. Well, this is better than I expected. Again, the speed kind of varies, but in this particular run, the serial fetch with a single thread, right? It takes 3 seconds to retrieve all 6 URLs. And in case of the 4 thread pools, it takes just a second. So we have a speed up of almost 3x with very minimal effort on our part, because all we're doing is we are keeping the same lambda function. We are just switching the map function to a version that can do things in parallel. So if we take a step back and think about how exactly we're able to improve the performance substantially and with not so much effort, and that is because the map function is a higher order function. So what it allows us to do is that we can focus on what exactly to do, and what to do, and that is the job of this lambda function, right? It actually opens the URL and fetch the web page and so on, right? So we can write that part, what to do, while the map function kind of handles how exactly to achieve what we want to do. And that how is, one version of the map function does it in series, and then the pool.map function actually does it in parallel. So it takes care of how to do it. And the difference between the different map function, as we see, it results in substantial performance improvement. Now, map doesn't seem like a terribly complicated idea, and it's actually been around for a long time. And we can see that it is very useful, and it has a cousin called reduce, and together they're called, well, map reduce. And they are the foundation for the very, very powerful data processing capability that companies like Google and Amazon, etc., have at their data center. So, and obviously, I mean, our version of pool.map, we have 4 parallel threads, but at these huge tech giants, their version of the map kind of distribute the Lambda function in parallel to thousands and thousands of machines. So, and that's why they are able to crunch so much data in short periods of time. So I hope this example give you another appreciation of the power of higher order function and lambdas.